right, let's plug it in. Ready? X equals, B is -1. So a negative and a negative is now a positive 1 plus and minus. A -1 quantity square is now what? 1 minus 4 times A is 1, C is also 1, all over 2 times 1. It looks very similar to one of the homework assignments we just got done. In the radical, what is it? Yeah, -3. So we are going to have 2 imaginary answers, which we just got done talking, okay? The trinomials from the sum of difference is going to be imaginary. So take out an I, rad 3, and then all over 2. These are 2 imaginaries. So total, right now we have 4 answers. We need to find how many more? 2 more. And they are from the last set of trinomials. A equals 1, B equals 1, C equals 1. All right, take 2 minutes. You guys finish that up. Box up your final answer. And then we need to bust out a Chromebook because we do need to sketch it out. Do imaginary answers show up on your Desmos? No. Okay, only the reals. All right. In your group, solve these, please. You're doing this one on your own.
Would A be x squared? It goes down the line like ABC.
ABC, yes, because in a quadratic formula, it's always ax squared plus bx plus c equals to 0.
Okay.
Yep. Okay, once you guys have your 2 more imaginary answers, you do need to take out your Chromebook. You do need to go to decimals.com, graph it out, and you need to sketch it out, okay? So this last sketch, you are on your own. Take out your Chromebook, guys. Sketch it out. You got some blank sketches, meaning that you're not doing your job. You should not have any blank sketches. Go straight to decimals.com. Don't do the students part. Because that's just decimals.com. Type in the equation, which is x squared. Okay. Do we have the 2 imaginary answers? What is it? X equals to what? -1 plus or minus I rad 3 all over 2. All right, there are the 6. Sketch it out. What shape do you see? U, okay. What are the 2 x-intercepts for your U? Right. What's the y-intercept? All right. So... By the way, the only time that you're going to get a line is when, what degree should it be if you want a line? A linear has what degree? 1, right? Linear is y equals mx plus b, and that x is just going to have a degree of 1. Currently, you guys should have everything sketched because I did ask you to sketch that on your own, right, guys? So if you haven't, sketch that out. Type it in and sketch it out for me. So go to decimals.com, type in example 4, and do a little sketch, please. How many times does it look like, look at example 4, how many times does it look like it's intersecting the x-axis? 3. That means you might have 3 real answers, right? But the degree is 3 anyways, so would you agree that that's all you're going to have? There shouldn't be any imaginary, okay? So this is an extra part of the notes. So it's going to start on 2.5. So all of your handwritten notes, you can just stick it on the top. Does that make sense? And then starting from 2.5, you can write on these. It's just an extra couple of sheets I have. Okay. Do we all have a U on number 7? Okay. Now for this one, we know decimal says we have 3 answers. Can someone help us solve this one? What would you do first? Super scary looking.
It is.
Everything's scary. It's Halloween month. All right, you have 4 terms. How do we factor 4 terms? How do we factor 4 terms? Draw your fence. After you draw your fence, what's the GCF for the first? 3. Negative 3x what? Square. What's left? X minus or plus? Plus. Yeah, we took out a negative, so this is now plus. 5, 6, 7, 8. Which one? 8. Then take out 11. X plus 8. 2 common factor. That's a good sign, right, guys? So x plus 8 times a quantity negative 3x squared plus 11 equals 0. X plus 8, that is a nice, easy answer. That first real answer is where? Negative 8. So nice. Okay. Now this one is not as nice, but it's not as scary. You're going to take a negative 3x squared. We are going to drop down the 11 and set it equal to 0. If we move 11 to the right side, it turns into a what? A positive or negative? Negative, right? Because it's minus 11. Then divide both sides by a negative 3. A negative 11 divided by a negative 3. So now we got x squared. Positive or negative on the right side? Positive 11 over 3. We need to undo a power of 2. So we are going to go in and do a square root. Every time we take a square root, students, there should be a positive and a negative. One big fat radical, could we rewrite it as 2 little radicals? We can't have radical on the bottom. So now what? Cry? I would? Yeah, me too. All right. But we won't. We're going to take it and multiply by rad 3 to the top and rad 3 to the bottom. Is this imaginary or real solutions? Real. It's an ugly one, but they're real. All of them are real. So if you graph it out on decimals, can you please sketch it now on your own? So this sketch, you're going to need to do it on your own. Because all of them are real, you would need to see how many times, by the way, it crosses the x-axis? 3, yep. So if you are not crossing over 3 times, you're graphing it wrong. So sketch it out. You are now sketching it on your own, and then we're moving down to the last 3 questions. Man, your screen is so dark. There you go. Uh-huh.
How does 11 not change?
11 notch. Oh, 33. Oh my gosh. See? Thank you, Colin. There you go. Thank you. Sorry, got too excited with the denominator being gone. So you guys have, by the way, in your decimals, the 33, square root of 33 over 3, about what decimals? According to your... So in decimal, negative 1 point something? In between what? Negative 1 and negative 2? Okay. I just need to know so I can mark it. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2. So in between -1, -2 are the two plus or minus square root of 33/3. And then -8's here. What's your y-intercept? Positive. Click it on decimals. It should tell you. Y-intercept is positive what? 88. Y-intercept is when x equals to what? If x is 0, what goes away? Everything except 88. So 88 is the only remaining value if x is 0. Okay, you sketch out the rest. Does it look like a heart attack? Go up, down, up, down. Okay. So when I stamp your notes, I am expecting you guys to have this all sketched out.
I still don't understand how to write down when it's like in the negatives like that.
Hmm?
I still don't understand how to like draw this down when it's in the negatives like this.
What do you mean, like it's in the negative? Let's double check. This is your -3x cubed. Oh, you're forgetting an x. 24x squared. That's why it's like looks super. There you go. So now it should be like a little bit. There you go. So now go up. Yeah. There you go. Tuesday and Thursday after fit, and then Wednesday morning. All right, guys. All right, let's go into the last three. Ready? 8. Oh, last 4, my bad. 8, 9, 10, 11, and 12. Okay. No, this is it, 14.4. X and y-intercept. To find x-intercept, students, y must equal to 0. Okay? So x int y equals to 0. I'm going to make the other line y int x equals to what? 0. Let's do y int first because y int is so easy for this first one. When x equals to 0, what happens? Everything goes away except what? Oh my gosh, that's so nice. So write it as an ordered pair. What comma what? What commas what? 0 comma -18. Okay. Now the other one, x-intercept, requires a bit more work, but we already know how to do this. We're going to take y. We will set it equals to 0. So now we have x cubed minus 2x squared plus 9x minus 18. Colin, there are 4 terms here. How do we factor this? Yeah, like fence it out. So GCF, Jacob, I on the first 2 terms. What do we take out, Jacob? Good job. So now, students, we're left with an x minus 2. The second 2 terms, they do have a 9 in common. So we are going to take that out. So we do have an x minus 2. Now, x minus 2, they are the same. That's a good sign, meaning that we are doing it correctly. So we're ending up with an x squared plus 9. All of this is equaling to 0. Take each factor and we set them equal to 0. This one, this one. The first x-intercept is nice and simple. It's straight up at where? Yep. So write it as an order pair. 2, 0. Now x-intercepts, okay guys? X-intercept, Luke, it has to intersect which axis? The x-axis. Right. Do imaginaries cross over anything? No. So that's why when we look for x-intercept, we're only looking for real solutions. But look, if we move the 9 over, what happened? It's negative. And then we're going to take a square root. If we take a square root of a negative 9, is that a real answer or an imaginary answer? Imaginary answer, students. So guess what? We don't need to worry about it. We don't need to worry about it in the x-intercept world. But when it says solve, then we do need to keep it, right? But for x-intercepts only, we don't need to worry about it. Okay, so this one, there are 2 answers total. One's an x, one's a y-intercept. We're going to do 9, and then we'll sketch both at the same time. So 9, similarly, I'm going to divide in half, so it's more organized on my paper. So divide it up. X int. JD, x int is when y equals to what? 0. Right. Y int, x equals to 0. Oh, I do like the y int on this side. What happens when we plug in 0 for the y? I mean for the x-intercept. My bad. What happens when we plug in the x equals to 0 for the y-intercept? Everything goes away. So straight up, y-intercept is 0, comma 0. Because everything goes away since 0 to any power is 0. Then over here, we're going to set equal to 0. So 0 equals 2x to the 4th minus 3x to the 3rd minus 20x squared. Okay. GCF. Enzo, what's the GCF? Good. Take out an x squared. So we are going to end up with 2x squared minus 3x minus 20. Okay. In your team, can you figure it out? Can you decide if this is factorable or not, please? So work it out together. You're on the money. You're on the money. All right, talk it out, guys. Figure it out if that trinomial is factorable or not. Did you talk to your team?
We did.
Did you prove it? Factorable or not? Did you? What did you guys make? How did you decide that's factorable or not? Did you try? What did you try?
5 minus 8. Anything that multiplies to negative 4 does not.
And then 5 times negative 8.
2 number multiply equals to negative 40? Add equals to negative 3? That's not possible? Is it possible?
Yes.
Oh, yeah. Give us 2 numbers. Multiply equals to negative 40. Add equals to... Thank you.
Of course.
He's so smart.
All right. So 2x squared. We said 5 and negative 8. So can I write negative 8x a positive 5x? Is that the same, by the way? Yeah, okay. Could I do 5x and minus 8x? Yeah, you can do any order you want. Okay, so fence it up because Colin said so. Take out 2x here. X minus 4. If we take out a positive 5, we also have x minus 4. Okay, when you guys write this, don't forget we have a GCF of x squared in the front, okay? So our 2 factors from that trinomial, x minus 4 times the quantity of 2x plus 5. We are expecting, if we said solve, there should be 4 solutions, right, students? Because the degree is 4. We look like we might be getting 4 real solutions, except one of it has a multiplicity of what? 2. All right. So this right here, this is where the multiplicity 2 comes from. Because it's an x times x, and they equal to 0. So that technically is 0 and then comma 0 again. But that's kind of silly to write it out twice, right? So that's 1. We're going to write it in order pair soon. But just give us a second. All right, so this equals to 0. 2x plus 5 equals to 0. Second x-intercept at 4. Minus 5 to both sides. 2x equals negative 5. The third x-intercept is negative 2.5. All right, order pairs. They should all have a y value of 0. So here we go. 0, 0. 4, 0. and then negative 5 over 2 comma 0. All right. Let's bust out your Chromebook and Desmos sketch. Type in the two equations, okay, and then let's start sketching those. Okay, so x-intercept is, look, bless you. Make it bigger. Let me see what it looks like. No, not. Okay, so do me a favor. Go to the wrench. Hit the wrench really quick, and then I want more of the y. So like do negative, let's say negative 100y. Is it? Okay. Yeah, looks okay. On this one, did you guys have just that? Right? It's not a straight line, by the way. Even though some of you guys, when you guys graph this out, you only see a piece or small part of the graph, and it looks like a straight line, but it's not. How about number 9? Does it look like number 8? Or it looks a lot more up and down? Yeah. Let's see. 2x to the 4th minus 3x to the 3rd. Okay, so let's see. I'll hit the wrench really quick. And then for the negative y, let's put in negative 150. Just delete the whole thing. There you go. Negative 150. I want to see what it looks like. There you go. That looks better. All right. So Jacob has, I'm just going to copy his graph here. 1, 2, 3, 4, 5. So we have 1, 0 here, 2, 4 here, and then negative 2.5, negative 1, negative 2, negative 2.5. And Jacob has a funky looking W. Am I correct? And then at 0, can you guys see that it's bouncing off and it doesn't cross? Because we just talked about 0 having a multiplicity of what? 2. Okay. All right, 2 more, and then we can call it an egg roll. And then go move on to your 4 questions in the homework. All right, x-intercept, straight up, y is 0. By now, that's always the case. Doesn't matter what function we throw at you. So 0 equals, oh my, it's a power of 3. Okay. All right, solve for it normally. Pretend it's an absolute value. So you still need to isolate the quantity. So to isolate the quantity, we're going to add both sides with what?
1.
Yep. So that will give us 1 equals x minus 7 to the 3rd. To undo power of 3, what do? We take the cube root it. Okay. Now square root, we would need 2 identical items to get it out of the square root. Cube root, you would need how many identical items? Yep. 1, it's a perfect cube, by the way, because it's 1 times 1 times 1. So cube root of 1 is always 1. Yep. Bless you. What's a cube root of negative 1? Negative 1, because it's negative 1 times negative 1 times negative 1. What's a cube root of negative 8? Negative 2. Cube root of negative 27. Yeah, so cube root, there's no imaginaries. Can you see that? Okay. So this one, cube root of quantity x minus 7 to the 3rd is now x minus 7. Add both sides with what? There's only one answer, one real answer. X equals 8. So x-intercept is 8, comma 0. Y int, x is 0. Ooh, we're going to need some big brain here. Here you go. Y equals 0 minus 7 to the 3rd minus 1, which is y equals negative 7 to the 3rd minus 1. What's negative 7 times negative 7 times negative 7? You do have a calculator, so feel free to use it. Oh, yeah, thank you. Negative 3, what? 43. Muchas gracias. Okay. So final answer, negative 3, 4, 4. So y-intercept is 0, comma, negative 344. Box that up. We're going to do 11 at the same time, and then we'll sketch it out with decimal after, okay? Let me just leave that up. If you are ahead, you can get started on 11. Try whichever one's easier. If x-intercept is easier for you, then do the x-intercept. If y-intercept is easier for you on 11, then do the y-intercept. Okay, so 0 equals negative 2 times x plus 5 squared minus 3. Step number 1, did we add 3 to both sides? After we add 3, guys, what do we do next? Okay, what's next? Divide by negative 2. Think of it like an absolute value, except the absolute value, whatever comes out of it, is positive. So don't distribute inward. So divide by negative 2. Keep in mind, we are looking for the x-intercept, not solving. So x-intercept must have imaginary answers. Is that a true statement? X-intercept, we must have an imaginary? No. If it's imaginary, we can stop, right guys? Is this giving us imaginary answer? Oh yeah. So imaginary. So guess what? We can stop. But if we stop, how do we write our answer? No x-intercept. Well, what would that even look like? Would it ever touch the x-axis? No way. So we're going to prove that in a little bit. Okay, y-intercept, it's simpler. We're going to chuck in 0. Ooh, what's 5 squared, y'all? 25. 25 times negative 2? Negative 50 minus 3? Negative what? 53. So we have one answer, 0, comma, negative 53. X-intercept does not exist. Now let's graph it to see if it touches. We're going to have to graph both. But this one, hopefully, our algebra is correct. If our algebra is correct, decimal should show that it doesn't ever touch the x-axis. Okay. Remember, you can always hit the wrench to move manually the x-axis and y-axis. Okay. By the way, does that look like number 10, that little sketch? Okay, thank you. And then what shape is number 11? Downward U. Very good. Does it touch the x-intercept at all? Someone give me the vertex then, since it's not crossing over the x-intercept. Where's the vertex for the last one? If you click on it, it should tell you. What do you guys have? Negative 5, negative 3, and Nicoletta agrees because that's what she has. Okay, 1, 2, 3, 4, 5. Uno, dos, okay. And then We're going to hit over the y-intercept here at negative 53. It's that green mark since I can't really have. All right. Take out your